Our topic for today is solving 3x3 systems using substitution. This is section 2.1 in your book. There are also additional examples in your book. This is for Algebra 2 for October 9th. Should be for a Friday. The essential question for today is how can you solve a system of 3 linear equations in 3 variables. This means that you will have 3 separate equations, and at most in each of them you would have 3 different variables. X, Y, and Z are commonly used. Of some background on notes. A linear equation in 3 variables will have a solution that is an ordered triplet. So far we've dealt with ordered pairs, which are X and Y. An ordered triplet is X, Y, and Z, and they always need to be in alphabetical order. And that's if the plane intersects, because whenever you have 3 variables, that means that you're going to have a plane instead of a line. This is if the planes intersect at exactly one point. There are 2 other possibilities. Your planes could all overlap, or your planes could all intersect at a line. So this is if they intersect at exactly one point. There are infinitely many solutions. If the planes intersect at a line, and no solutions if there are no points in common. With all 3 planes. You're going to have some steps for solving these 3 variable systems. So your steps for solving a 3 variable system with substitution. Tomorrow or on Tuesday you'll learn a separate way. A 3 variable system using substitution. Your first step is to solve one equation for one of its variables. Sometimes this is already done for you. Step 2 is to substitute an expression from step 1 into the other 2 equations. You can't substitute it into the one that you already solved for a variable. It has to be into the other 2 equations to obtain a linear system in 2 variables. Now that you have a linear set of linear equations in two variables, you're going to solve these like we have been doing. Solve your new system for both variables. And once you're done with that step, you're going to substitute the values found in step 3 into the original equations. And solve for the remaining variable. Once you have completed those steps, your next, you do need to know a couple of important notes. Okay, the first is if you obtain a false equation, such as 0 equals 1 or 2 is equal to 5, anything like that, in any of the steps, doesn't matter which step, in any of the steps, then you're going to have no solution. The system has no solution. If you obtain an identity is something that is always true. So if you obtain an identity such as 0 equals 0, the system has infinitely many solutions. Right? So now we need to see a couple of examples of these. So our first example. And I took this example from number 9 on page 64 of your textbook, and you can find that textbook either the hard copy or you can find that in the dynamic textbook at bigideasmath.com. And your example is 12x plus 6y plus 7z is equal to negative 35, and 7x minus 5y minus 6z is equal to 200, and x plus y is equal to negative 10. My first step is going to be to solve an equation for a variable. And I'm going to choose this bottom equation and I'm going to solve it for x. So step 1, I want to get x by itself, so I'm going to subtract y from both sides. So I get x equals negative y minus 10. My next step is going to be to substitute that into my other two equations, this top one and the middle one. So I'm going to have 12, but instead of x, I'm going to put what it's equivalent to. Negative y minus 10 plus 6y plus 7z is equal to negative 35. My other equation will look like 7, but instead of x, I'm going to put in negative y minus 10 minus 5y minus 6z equals 200. I'm going to solve my equation on the left first, or I'm going to simplify it. So I'm going to distribute the 12, so I'll get negative 12y minus 120 plus 6y plus 7z equals negative 35. I'm going to combine my negative 12y and my 6y and get negative 6y. I'm going to add 120 to both sides. So I'll have plus 7z equals, and negative 135 plus 120 is going to give me 85. Alright, Over on this side, I'm going to distribute, so I'll get negative 7y minus 70 minus 5y minus 6z equals 200. I'm going to combine negative 7y and negative 5y to get negative 12y minus 6z is equal to, and I'm going to add 70 to both sides to get 270. So those are my two equations. So that was step 2 whenever I substituted them in. Step 3 is going to be to solve this system of two equations with two variables. So I have negative 6y plus 7z is equal to 85, and negative 12y minus 6z is equal to 270. And I'm going to solve these equations using elimination. I'm going to multiply my top equation by negative 2, and that will give me 12y. Negative 2 times 7z is negative 14z is equal to negative 2 times 85 is negative 170. And on the bottom I'll have negative 12y minus 6z is equal to positive 270. My 12y's cancel out. Negative 14z minus 6z is negative 20z is equal to a negative 170 plus 270 is going to be 100. Divide both sides by negative 20. Z is equal to negative 5. Now that I've found z, my next step is going to be to plug it into one of these two equations to find y. Either equation works, so I'm going to choose this top one. So I'll have negative 6y plus 7, and I just found out that z is negative 5 plus 85. So negative 6y, 7 times negative 5 is negative 35 plus, is equal to 85. I apologize, is equal to 85. I'm going to add 35 to both sides, and I get negative 6y is equal to 120. Divide by negative 6, y is equal to negative 20. Then I'm going to plug that in. Step 4 is to find my remaining variable. I'm going to plug that into this top equation. Sorry, I wrote off the paper a minute ago. So x plus y, which is negative 20, is equal to negative 10. So x plus negative 20 is equal to negative 10. Add 20 to both sides, and x is equal to 10. So my ordered triplet is going to use all three of those. It's going to be at 10, negative 20, negative 5. That is example 1. We've got 2 examples to go. Alright, I've got to start another page. So this is 2.1, notes continued. Example 2. Example 2 also comes from your book. It's number 10 in your book on page 64. And it is 2x plus y plus z equals 12. 5x plus 5y plus 5z equals 20. And x minus 4y plus z equals negative 21. That is your equations. You may notice that this one is slightly different than our first example because there are 3 equations. Each equation has 3 variables. So my first step is going to be solve one of them for one variable. And I'm going to actually choose this middle one, and I'm going to solve it for x. So I have 5x plus 5y plus 5z equals 20. Subtract 5y, subtract 5z. And normally I wouldn't pick one that has a coefficient, but here all of my numbers are divisible by 5, so I won't have any fractions or decimals. So divide those all by 5. and I get x equals 4 minus y minus z. Step 2 is going to be to substitute this into my other two examples. So 4x in my first, I'll do my first equation first. I'll have 2, and instead of x, I'm going to have 4 minus y minus z plus y plus z equals 12. And my last equation, this one down here at the bottom, I'll have, instead of x, I'll put in what it's equivalent to, 4 minus y minus z minus 4y plus z equals negative 21. I'm going to go ahead and distribute. I'll get 8 minus 2y minus 2z plus y plus z equals 12. Then I'm going to combine my like terms, and I'm going to subtract 8 to move it over to the other side. So negative 2y plus y is going to give me a negative y. Negative 2z plus 1z is negative z equals, and 12 minus 8 is 4. On this side, I'll have 4 minus y minus z minus 4y plus z equals negative 21. So I'm going to subtract 4 and combine my terms. Negative y plus a negative 4y is negative 5y. Negative z plus z cancels out, so I'll have negative 5y is equal to negative 25. I can divide this by negative 5, and y equals 5. This makes it pretty simple to plug that back in for y here. So negative 5 minus z equals 4. Add 5 to both sides. Negative z is equal to 9. Divide by a negative 1, and z is equal to negative 9. My last step is to go back and find x. Sorry, this was step 3, solving it for both of those. Step 4 is to go back and find x. So I'll have x is equal to 4 minus y, which is 5, minus z, which is a negative 9. So 4 minus 5 plus 9. 4 minus 5 is negative 1. Negative 1 plus 9 is 8. And then I'm going to write this as an ordered triplet. My x, which is 8, my y, which is 5, and my z, which is negative 9. We've got one more example, and it is going to be on the back of this page, example 3. And example 3 is also from your book. It is number 18 on page 64. And it is x is equal to y minus z. X plus y plus 2z is equal to 1. And 3x plus 3y plus 6z is equal to 4. And step 1 is already done for you. If you choose your top equation, it is x equals y plus z. It's already solved for one of the variables. Step 2 is going to be to substitute that into our other two equations. So I'm going to plug that into my second equation. Instead of x, I have y plus z plus y plus 2z equals 1. And 3, and instead of x, I have y plus z plus 3y plus 6z equals 4. So combine like terms, I'll end up with 2y plus 3z equals 1. I apologize, this is minus z. This is minus z, so this would be a 2y plus a z. Negative z plus 2z is plus a positive z. This is also a minus z. Distribute, I get 3y minus 3z plus 3y plus 6z equals 4. So here I have 2y plus z equals 1. Over here, 3y plus 3y is 6y. Negative 3z plus 6z is 3z equals 4. My next step is going to be to solve these. I'm going to solve these using elimination. So I'm going to, I can see that I have 6y right here, and if I multiply this equation by negative 3, that'll be able to cancel out my y. So I'm going to do negative 3 times 2y plus z equals 1, and 6y plus 3z equals 4. So if I multiply my top equation by negative 3, I'll get negative 6y minus 3z is equal to negative 3, and 6y plus 3z is equal to 4. My y's will cancel, my z's will cancel, so I'll end up with 0 is equal to 1. And those are never equal, so this is no solution. For more examples, you're going to want to check out bigideasmath.com. Go to the Student Dynamic ebook. Chapter 2, Section 2.1. And anywhere you see a play symbol like this, you can click on it. I apologize. Click on it and it will work out more problems that are similar. Your assignment is also on bigideasmath.com. It is 2.1. It will be due next Friday, which is October 16th.